So this hour we will introduce another topic which is very important as well, which is a mobile network. That means 3G, 4G, or 5G network. Okay. So 4G or 5G cellular network, they are the solution for wide area mobile internet, right? So currently it is well separate deployment and used. Okay, so there are some statistics right here. So for 5G or 4G, their transmission rate should up to 100 megabit per second for one user. And those standards or those mechanisms are under control by 3GPP. That is an organization. Okay, that is an organization. And for 4G, okay, that is another method called long-term evolution standard, LTE. So when you use 4G network, okay, in your cell phone, it always show LTE or LTE plus, right? It sometimes LTE stands for is the standard for 4G network, the fourth generation cellular network. Okay, so that's very simple. So we simply just take a at the right hand side. Okay, the 4G, 5G cellular network is a little bit different from wired internet. Okay, so for 4G and 5G, we still send layer 7 message, layer 4 segment, layer 3 diagram by using your cell phone, right? But the underlying layer 2 and layer 1 is different. Okay, in computer network, we have Wi-Fi, we have Ethernet, right? But in 4G, 5G, we don't use Wi-Fi or Ethernet as the layer 2 protocol. But we will not introduce those layer 2 or layer 1 protocol in our class because it is very complex. So because this class is called computer network, not cellular network. Okay, so we will not introduce the layer 2 and layer 1 mechanism used by 4G or 5G. Okay, and the difference between 4G and 5G or Wi-Fi is that when you go to classroom, you connect your device to Wi-Fi network, right? But when you leave classroom and you simply just disconnect your Wi-Fi and go to another classroom and connect to the another access point, right? But 4G 5G network is a little bit different. When you use your cellular phone and you keep walking, your cell phone will associate with a cellular tower, right? But when you keep walking, you may need to change your association from one cellular tower to another cellular tower. Well, so when you do such kind of, we call it handoff. Handoff is a terminology, okay? When you hand off from one cellular tower to another cellular tower, usually your connection, for example, if you are watching a Netflix movie, this movie should not stop. You can smoothly move from one cellular tower to another cellular tower in 3G or 4G, 5G network. But in Wi-Fi network, if you just keep moving from one access point to a next access point, you may change your IP address. So when you change your IP address, your layer 4 socket may be broken, and at layer 7, your Netflix application may not function correctly. So that is the difference between Wi-Fi network and the purpose of Wi-Fi network and 4G, 5G cellular network. So the mobility of cellular network is the first class service, is very important things. We will discuss mobility next hour. Okay, and in Wi-Fi network, we don't have identity, right? But in cellular network, you have a SIM card. right? To represent who you are and what carrier you use. So the business model is users subscribe to a cellular provider. So you have a home network. For example, you use NTT Docomo, you use Taiwan Mobile, you use AT&T, you have a home network. You cannot use others' cellular tower unless they have some contract or some mechanism so that you can share a signal sent by the other cellular tower from other provider. Okay, so let's see. Of course, we have several generation of cellular network. Okay, that is the first generation. Okay, the first generation is very simple. We as we introduced in previous class. Okay, we have FDMA, TDMA, frequency division. We have time division, and we have code division. So in the very early generation, in order to serve many users in a single cellular tower, we will divide time into different time slots. We'll divide the large spectrum into several different frequency band, and we assign different code to different users. So we can have several different users in one single cellular tower. That is called GSM system, right? The first generation of your cellular network. So for each user, they use 200 kHz frequency band for each user, and we have 8 time division cell. And of course, we can assign different code division. So we use frequency division, time division, and code division collaboratively to serve many different users. So that is the first generation of cellular network. Okay, the second generation is 2G, right? And at that moment, we simply just want to use the voice services. This structure is looks a little complex, but actually it is not that complex. So again, we have several tower, and we have several different layer 2 and layer 1 protocol and mechanism, so that your mobile phone can associate with the cellular tower. So after the cellular tower, we have a control system called BSS. That is a basic station system. One BSC can control several towers. Okay, so as you can see that we have two BSS and we have two BSC, and after that we have MSC, which is the mobile switching center. I think you remember that in the very first few hours of our class, we introduced how phone network works in early days, right? We have a lady, we have an operator sit in a switchboard, right? So if you want to talk to from one number to another number, the operator need to use a wire line to connect the slot of one number and the other number, so that we can create a circuit switch line between these two numbers, right? So right here in 2G network, it's very similar. So for those mobile switching center MSC, of course they are automatic machines. They can create the circuit switch line between different numbers, right? So if you want to make a call, right? So you first associate with the BSC by using different frequency, different time division, different code division. And the BSC will allocate resources with the help of MSC. So they will create a circuit, for example, to another BSC, for example, right? So for example, right here. For example, this number A, number B, we have a self. They will create a circuit with the help of BSC and MSC. And after that, the resources will be released between BSC and MSC. And of course, if you want to call a number not in this system, for example, you want to call public phone network, okay? We call it PSTN, public phone telephone network. you want to call a number right here, okay? And then this gateway MSC will create another circuit switch route from your cellular phone to BSC, to MSC, to gateway MSC, and to the PSTN network. Okay, so and of course for BSC and MSC, the one of the important things that need to do is paging. So every number, every cell phone in the BSS need to register its SIM card information, its phone information to BSC and MSC. So when a call comes into the switch center, it knows where you are, which BSC you are, or which tower you are. So that is called paging. Okay. And if you switch from one tower to another tower, BSC and MSC, of course, they know you switch from one tower to another tower, so they also have to deal with the handoff problems. Okay, I think 1G, 2G is very simple. So in our textbook, we simply just introduce a very basic concept of 1G and 2G network. So the most important thing is 3G and 4G in our textbook. Okay, so at 3G we have some other purpose and request. Not only voice, we have data right now. So that is in 3G network. You have to capability to access the phone network and the internet. So you can see that right here, it is exactly the same as 2G network. That means we still have controller. Okay, so we have another name called radio network controller. So you don't have to remember all this name because we have too many names right here. But you have to know for each tower we have a controller. So in 3G it is called radio network controller, and again we have MSC, we have gateway MSC, we have PSTN. So this line, okay, this mechanism still exists in 3G network. But when you want to send data to internet, after RNC, after radio network center, or after the radio access network, okay, and of course it has a name called UTRAN, but I don't think you need to remember the things, okay. And we have different, and of course, because it's a 3G network, it's the next generation network. So we have a new layer 2 and layer 1 mechanism and technology. So right here we have WCDMA, HSDPA, HSPA. They are just simply some new technology that you can use in layer 1 and layer 2. So you have a higher transmission rate. You have some other mechanism to include even more user in a single tower. Okay, so but you don't have to care about the things. Okay, but when you want to send your data to public internet, okay, the other route is at the right hand side. We have a core network right here. Okay, and that is called GPRS. That is the name you need to remember, GPRS. Okay, so we have SGSN, GGSN, and right here, take a look at this one. They are simply just as a router. So your telegram will be sent to SGSN and GCSN and goes to the public internet. Okay, the functionality of SGSN and GCSN is a little bit different. So let's take a look at right here. SGSN is responsible for delivering telegram. So take a look at this. For now we use datagram because it is a packet. It is an IP packet. Okay, to or from the mobile node in radio access network to which the SGSN is attached. So the signal, the information need to be processed by SGSN, okay, and then forward to GGSN, because GGSN acts as a gateway. That is a gateway router connecting multiple SGSN into the larger internet. So basically it is a router. It is exactly the same as router. Okay, so we have two different approaches. One mechanism, one is for voice data, the other is for internet data. Okay, they have two different mechanisms to deal with those things. Okay, so after that, okay, you can imagine that. Why do we need to separate mechanism to handle data and voice? So after that, so 4G is, I think this is announced and deployed about 10 or 12 years ago. So at that moment, we already know how to transmit voice information by using packet. So what that is called voice over IP. So for 4G, okay, the first things we have to know is that we don't want to keep the conventional, the traditional voice mechanism. So a unified OIP network architecture. So no matter you want to transmit a voice, or you want to transmit data, all of the data and voice are encapsulated in IP diagram. So basically, no voice information. All of them are data. And then we can use the computer network mechanism to deal with those data. Okay, let's first take a look at the left-hand side. Okay, so again, we have another names. So all the mobile device is called UE. So that is called user equipment. Okay, in 4G. Okay, and UE can be a smartphone, tablet, laptop, something like that. And for HUE, as we mentioned before, we have a SIM card, right? We have a SIM card, and we have a identity, okay, called IMSI. Okay, so that is the devices. Okay, so let's take a look at the first thing. Since 4G would like to eliminate the voice, the switching, those mechanism. Now we have several different rows and machines right here. Okay, we will introduce what is the functionality of each devices. Okay, so first, OIP core. Okay, so at the left hand side, that is the radio part, and the right hand side, that is the OIP enhanced packet core. So sometimes we call it core network. Okay, core network. Okay, you have to know that the figure right here. Okay, the tower, all those devices, ENO, B, MLS, HS, S gateway, P gateway, all those are built by the telecom company. For example, AT&T and T-Mobile, Zhonghua Telecom, something like that. So you have to think about it. At the right hand side right here, that is internet, right? Internet is built by lots of ISP, right? But at the left hand side, although there are some other, there are many different routers, different rows at the left hand side, but those core network and the radio access network, they are built by one single telecompany. So basically, you can view it as a private network. Okay, but at the right hand side, after P gateway, okay, that is the internet, that is a public internet built by ISPs. But at the left hand side, all those blue parts and this radio tower are built by a single carrier, by a single killer company. Okay, so then let's take a look at what right here. Okay, so there's no separation between voice and data. All traffic carried over IP core to gateway. Okay, so let's first take a look at ENO B. ENO B, you can simply just think it is similar to RNC in 3G network is very similar to BSC in 2G network. So it's just a name, okay? We will talk about its functionality later, okay? So that is, and we will not talk about ME and HS in this hour, okay? So what is S gateway and P gateway? So let's take a look at right here. S gateway is serving gateway S gateway, okay? It is a data plane mobility anchor point. We'll talk about anchor point later, okay? All UE traffic will pass through the S gateway. So that means all the voice packet and data packet will be encapsulated in certain way, okay? And will be sent, will be received by the tower, right? By the node B, and then will be forwarded to S gateway. The S gateway has a very important functionality, which is right here, charging and billing. So that is the reason why those telecompany, they know how many packets you send, how long, how many calls you call, and how long they are. Because we have an S gateway right here, because all the traffic will pass through S gateway. So charging and billing is a piece of cake. Okay, and again, it has a low traffic interception. Since all the traffic will pass through S gateway, so if you want to, of course, it needs some. If you have some security concern, okay, the government can issue the court, okay, can issue a certification or issue some certification by the regulation, so they can hear what you say in your 4G network or 3G network. Okay, of course, it should be under control by the court. Okay, but the functionality is done by S gateway. Okay, after that, okay, it depends on what is the data or the voice goes to. Okay, so all the information will again relate to pass through to P gateway. Okay, so P gateway right here. P gateway, okay, UE diagram will be encapsulated at the E node B and tunnel to the B gateway. Of course, it will pass to the S gateway first, okay, and S gateway will forward this will further tunnel the data to P gateway, okay, with QoS, quality of service, okay, through the 4G network, through the 4G core network. And if it goes to the internet, and then at the right hand side we have internet, it is a call to some other telecompany, and it will go to the internet, to the P gateway of other telecompany. If you call the number in the same carrier, then the P gateway will deliver the packet, the voice, to back to some other E node B to pay to perform paging. Okay, so that is the functionality of P gateway. And right here we have a very special thing. It's called QoS, quality of service, because as I mentioned before, because all the blue devices are controlled by a single carrier, by a single telecompany. So basically, they can do quality of service. As mentioned before, because at the right hand side in the internet, all the routers are belong to different ISP, right? So basically, they do not do any quality of service or type of service. There's no priority in the internet. But at the left hand side, because all the machines are controlled by the telecom, so basically they will they can set priority to different packet. For example, voice packet always has higher priority, so voice packet can quickly pass through all these routers to the internet. But if the voice packet will be forwarded to the internet, and there's no quality of service in the internet, but there indeed has quality of service in the core network. in a 4G to 3G core network. Okay, think about these things. Okay, and then we have some slide to introduce the concept of different part. Okay, so again, so for a base station E node B, okay, it may have several towers. Okay, for each towers we have a mobile device. Okay, and you can see that it is a cell, right? It is a hexagon shaped cell. Okay, so in the core network we have two rows which manage mobility and home service. We'll talk about later. Okay, and we have S gateway to do the building functionality, and internet is at the right hand side. If the packet, voice packet or data packet need to be forwarded to the internet, it will pass to the P gateway. So the base station is the edge of the carrier network. It manages the layer 2 and layer 1 wireless radio resources. It need to deal with TDMA, FDMA, CDMA problems. Okay. Coordinate device authenticate with other elements. We will not go over any authentication mechanism in this class, okay? But you have to think about one thing. In campus, okay, if you want to associate with a Wi-Fi, you need a password, right? So again, in a cellular network, okay, since we know who you are because we have a SIM card number, serious number, we have SI, you have to authenticate yourself by using your SIM card information. Okay, so that is the base station. Okay, now we talk about what is MSS. Okay, so the home, HSS, the home subscribe service store the information about mobile device for which the HSS home network is their home network. So basically, your SIM card is associated with some carrier, right? So you can only use the base station E node B built by the same carrier, right? You cannot use a T-Mobile SIM card and try to associate with AT&T tower, right? Unless T-Mobile and AT&T they share some tower or they have some contract to let you do so. Okay, so MME, HSS is the home subscriber service. They know who you are. They know what is your IMSI and SIM card serial number. They have to maintain such kind of information. And when you do handoff, MME and HSS should update their information. Okay, so that is. So again, we talk about this, right? S gateway and P gateway have several different functionality. Okay, S gateway do building and interception, and P gateway do is a gateway. Okay, and it really depends on different settings. Okay, as I mentioned right here, sometimes the IP address you obtain, your UE obtain is a private IP address. So that means the P gateway is also an entity server. But sometimes if the carrier decide to to give you public IP address, and then P gateway can simply just give you a public IP address. Okay. Then MME. Okay, MME to deal with mobility things. So if you switch from one tower to another tower, MME knows that. Okay. Authentication, again, right here, device authentication. Okay, device to network and network to device. They coordinate with the mobility home network HSS. Again, mobility management. Device handover between towers, and MME and HSS knows that. And they will keep tracking where you are, and if someone want to call you, they page you because they know which tower, which E-node you are. Okay, so again, they have to tell the E-node where is S gateway and where is P gateway. So they have to they will set two different tunnels to tunnel your diagram from node B to S gateway and from S gateway to P gateway. So let's take a look at this view graph. That is more easier for you to understand that. Okay, so when you send your layer 7, layer 4, and layer 3 message, segment, and diagram. Okay, so right here for 4G network, it has its own layer 2 and layer 1 mechanism, but we will not introduce those protocols. But you simply just think, okay, that is another different layer 2 devices. Okay, so your friend will be transferred from your cellular phone to your base station. Okay, so LTE layer 2 link layer protocol. Okay, packet data convergence. Okay, they have header, they have compression, they have encryption, which is a little different from Wi-Fi frame and Ethernet frame, right? So they have a radio control protocol, so they do fragmentation, they do a reassembly, but in Ethernet and Wi-Fi we don't do fragmentation and reassembly, right? And they have reliable data transfer, but again in Wi-Fi and Ethernet we don't have reliable data transfer. But LTE layer 2, they have such kind of functionality. Multiple access, as we mentioned before, we have TDMA, LDMA, FDMA, and CDMA. They can include lots of users in a single tower. That is the design of their layer 2 protocol. But we will not cover this part. Okay. So again, so you simply just go over these pages. Okay. They have FDM, they have TDM, they have OFDM. Okay. They have I think 0.5 ms time slot over 12 frequency. Okay, the target is 100 megabit per second. That's a good enough for you to know. Okay, that is what I want to say is that at the left hand side, right, the green part is the diagram you sent from your UE, from your cell phone, but the yellow part is the layer 2 and layer 1, which is we don't care right now. But you can send a friend from your cell phone to the base station, right? But after the base station get your friend, it will further create a tunnel from base station, which is node B, to your S gateway. So the red tunnel right here, you can see that I draw a green box right here, right? So the green box, your datagram will be encapsulated in another UDP segment. And the source IP is from the base station, the destination IP is the S gateway. So here we have a tunnel. The tunnel encapsulates your diagram in another UDP protocol. Okay, and inside that is called GPRS or GTP. Okay, so the source is the base station and destination is the S gateway. So the S gateway will get your green diagram, and S gateway will try to do building functionality. And after that, the S gateway will set another tunnel right here. That is the purple one. Okay, the purple one between the S gateway and the P gateway. Okay, so again, they have a new physical layer link layer. Basically, they are fiber. Okay, they might be 10 gigabit Ethernet or some other fiber layer 2, layer 1 protocols, and they have an IP address. The IP address is tunneled from S gateway to P gateway, and again, they use GPRS protocol GTP to encapsulate your green diagram and send it to P gateway. So after P gateway, they will unpack the frame, unpack the diagram, unpack the UDP, unpack the GPRS protocol, and then they pretend, okay, that we have a green diagram. And as we say, P gateway is a router, so it will try to route your diagram to internet. So that is how 4G network works. I think this view graph is the most important one for you to understand how actually 4G network, core network works. Okay. So the next one we will talk about a little bit more about association. But basically, you use your cell phone to associate with a tower. It is very similar to you use your, for example, laptop to associate with your Wi-Fi AP. So we have 4 steps right here. The first step is the tower will broadcast signal every 5 minutes millisecond on all frequency. So that is exactly the same as beacon we introduced in Wi-Fi, right? There are several frequencies can be used by the tower, and for every 5 milliseconds, it sends a broadcast frame. Okay, I use the word frame. Okay, like beacon, to its in all frequency channel. So your cell phone will receive those beacon frames to understand, okay, what is the information, what is the setting of this tower, right? So step number 2, mobile find the primary signal and allocate second signal channel in signal to this frequency. And that is a little complex, but we simply just skip this one, okay? So mobile will find information broadcasted by the BS, right? What channel did you use? What is the bandwidth? What is the configurations? What is the carrier information? The mobile get information from multiple base stations, multiple cellular network, okay? But the mobile will choose one of the tower to associate with the preference for home carrier, of course, and then to do some authentication mechanisms to establish a state, to set up data plan, something like that. That's very similar to Wi-Fi. So after that, layer 1 and layer 2 is okay, is done. And then we continue to, for example, send a DHCP packet to get the IP address from the P gateway. Okay. And again, as we mentioned before, we have to control the power to do power control, right? So as in Wi-Fi and Bluetooth, LTE mobile, okay, they may put radio in to sleep mode, okay, but we simply just skip this one. Okay, we know we have different type of sleep, which is good enough. Okay. So the different, as I mentioned before, the difference between Wi-Fi network and cellular network is that in campus network, if you connect to a Wi-Fi AP and then you move to another AP, simply disconnect the layer 1 and layer 2, right, and associate with the new AP and get the new IP address and create a new socket and so on and so forth. Basically, you simply just disconnect to the previous BSS and connect to the new BSS, right? But in a cellular network, okay, when you move from one tower to another tower, or when you move from one carrier to another carrier, your connection should still keep working. So basically, at the left-hand side, we have a home network. For example, you use AT&T carrier, okay, and you have your home network is AT&T. So you have a home SS, you have a home ENOB, you have a home P gateway. But when you move your cellular phone to another visit mobile network, for example, T-Mobile. For example, in some area or in some, for example, national park, maybe there's only very limited tower that you can use, and that is not your home network tower. So you do roaming, right, to some other visit network, and maybe your home network and this visit network, they have a contract. So that means you can roam to the visit network to use the tower provided by the visit mobile carrier network. Okay, at this moment, the situation become a little bit complex because there are some building problems, there are some mobility problems need to deal with. I will talk about this later. Okay, so your home network address should identify the service and information for home network and roaming. Your home network HSS still need to keep track where you are, what is the visit network you visit, what is the P gateway they are, what is the tower you use, the visit tower you use. Okay. So we will not talk about much about 5G because 5G is a little bit new, but the target of 5G is 10 times increase the bit rate. So 4G is 1 megabit per second, so 5G is 1 gigabit per second. And 5G has new radio frequency. Okay, FR1 is to 6 gigahertz, and FR2 is from 24 to 52, and it is a millimeter wave frequency. It's not backward compatibility to 4G. So for some 4G 5G carrier, they need to buy new machines, new tower, new antenna, a lot of new things. Okay, we will talk about MIMO later. Okay, so because of the layer 1 and layer 2 limitation, the cell diameter is much less than 4G, because in 4G a tower can serve around, I think around over 1 kilometer. Okay, the range is a little bigger, but in 5G network that is much smaller. Okay, that is we stop right here. That is a very brief introduction to 1G, 2G, 3G, 4G, and 5G, and then we'll talk about another important topic, which is mobility. We talk about when you handle between towers, when you go aboard and use the visit network. How do they do so? So we stop right here.